My talk's not a repeat of last year's, although in some ways it may appear that I'm kind of running with the same thing, because naturally when I was here last year I was talking about future planning in Bouncy Castle and very confidently describing how we completely sorted everything out. And so I'm here this year to talk about future planning in Bouncy Castle and explain very confidently that we've sorted everything out, unlike last year when we thought we'd sorted everything out. And yes, I could probably get quite a few talks out of this. So, first thing I'm going to talk about is a thing called the sunset. While it looks like there's an awful lot of serenity, the reality is that this thing's based on an act of Congress called FSMA. Now, FSMA is a very good choice of name because it's what we'd call onomatopoeic in the sense that it's the sound your bank balance makes when you find out you're in violation of it. What basically happened, though, is that Congress passed this act in concern of US government agencies using software that was too old, basically. Now, NIST actually noticed this and then thought they'd join in. So in June 2016, they announced, quietly as it turned out, that they were going to introduce a 5-year validation sunsetting policy. And then last year they actually said, okay, we're going to start next year. And of course, most of us went, sure. Just like you were going to tell everyone that they couldn't use TLS 1.0. But at the start of this year they did. So a whole lot of people actually found themselves on what's called the historical list. So previously what used to happen with FIPS modules, and this was our expectation when we were originally doing our FIPS module, was that you'd progressively lose the certificates that were associated with your module. You know, like you couldn't use DES anymore, so they'd take that one out. DSA with 1024 bits for signing would become too old-fashioned, so they get rid of that. But you know, the module itself would kind of keep traveling along. It'd just be doing less and less. What's happened now, of course, is that they've said, okay, 5 years, that's it, done. So a whole lot of people found themselves on the historical list at the start of this year. And basically, yeah, the cut-off date is 1st of Feb. So anything certified prior to the 1st of Feb 2013 basically got shut down at the start of this year. Now, the question is, because, I mean, what does that mean? I mean, does being on the historical list mean that, you know, you can apply for national trust sort of funding or something? Unfortunately, it doesn't. What it actually means is that you can't actually be used for procurement by federal agencies. So if you're in a situation where you've deployed an application on top of a module which has actually ended up in the historical list, suddenly you can no longer sell that module to the US government. Now, the disturbing thing, of course, is I can't speak for governments all across the world, but one of the reasons I'm talking about this today is because what NIST tend to do about these things tends to propagate to other people. I mean, the Australian government is already talking about following suit. I'm sure other people will too. Now, you do have an out if you're on the historical list, but the out is that you have to get a proper risk assessment and a risk management decision has to be done. So then, you know, if somebody's actually looking at the idea of trying to run your application, which is running this module that's ended up in the historical list, they're probably going to have to get an external consultant in to do an assessment. They might be paying lots of money for this, there might be lots of paperwork involved, and they might think, look, you know, I really might just go and buy this other product. So it's not great. The other thing that's also happened is, as part of this, is that previously what would happen when you actually, so say for example we use 1.7, 1.8 is what we're certified on, we could have gone, okay, we want to get certified on 1.9. Previously what would have happened is we'd have just gone out, gone to a testing lab, generated some vectors, shown that the vectors passed. The testing lab would have written a report for NIST, they would have sent that in, everything would have been fine. What happens now though as well is that as part of this whole thing of NIST trying to make sure that people are maintaining the curve, is that if you actually apply for a new platform, not only do you have to show that your test vectors pass, but you also have to show the module is actually compliant with the current IG, which is implementation guidance, that's existing at the time you're doing the application. So, for example, at the moment you can use SHA-1 and FIPS approved mode if you're doing TLS, because it's required by some of the protocol. That may well change. So, for example, we might have a module today which allows you to use SHA-1. The implementation guidance might suddenly change and say you can no longer use SHA-1. We may have a vendor who we're working with who actually comes along, it's using a module, they go, oh, we need to run this on Java 1.11. We go to NIST, we go, yes, send us the test vectors. These people are using 1.10, they don't want to change. We run the test vectors, they all work, it's all fantastic. We send them back to NIST, and then NIST goes, hey, hang on a sec, your security policy says you can use SHA-1. And we go, well, of course. I mean, that was what it was when we did this. I mean, blah, blah, blah. Oh, no, not anymore. And so both from our point of view, there's an issue because it means we actually have to recertify the module using a 3-sub, which I'll talk about in a minute. And also, obviously, from the point of view of the actual end user who's got their application, suddenly they've found out that they can't deploy on Java 11. So restarting the clock itself, as I said, you have to do a 3-sub. Now, a 3-sub basically is a maintenance release where you've done some sort of enhancement. You've either added an algorithm, you've broadened the scope across which it can be used. You haven't done something like, for example, which I believe somebody did try, was you've gone, okay, I'm now version 1.3.0, and then you change that string and then resubmit the module. People do try that. That doesn't work anymore. Yeah, it's all about the implementation guidance as it stands now. The other thing, of course, is with the 3-sub, you're going, okay, I've expanded the functionality of my module. This means I have to submit a report which includes the code changes. These code changes have to be reviewed by the lab. The lab has to write a report on that because you're rerunning the test vectors as well. So it's more paperwork and more money. Other things that we need to keep in mind about the way things have changed since I was so confidently standing here last year, well, actually I was downstairs, talking about how we'd actually had everything under control, is Java's gone to this 6-month release cycle. So Oracle's actually already removed support for Java 9 and Java 10. I'll talk about that more in a minute. And they've gone to this idea of LTS releases that we've heard about. The other thing, of course, is NIST to just keep on doing what they do. And, we've had new algorithms. I'll talk a bit more about format preserving encryption later. I've actually got an example of it that I can show you now. And you'll be able to see that, as the cipher goes, even though it's actually now a standard, it doesn't really look anything like any of the ciphers that we're currently using. And then, of course, there's the post-quantum competition, which I suspect we'll be hearing more about too today. Certainly, hopefully, in the crypto agility talk, because this is becoming a real issue for all of us. So I'd probably have to say, in terms of NIST's position on the 5-year expiry date, it's probably not a bad call, especially in the situation we're currently facing where technology is going this way, the safety of our algorithms is going that way, and we're all trying to run in the middle and keep everything afloat. The issue, of course, that you have is that most applications, especially large government ones, people invest quite heavily in these, and when they're deployed, the idea is that they would be deployed for a 10, 15, even 20-year period. Now, if you really want to get someone's attention, a great way to do it, I suspect, would be to walk into their office and say, our crypto module's about to get archived. And, they'd probably be sitting there going, oh, really? Well, that doesn't sound great. Well, can't we just upgrade it? And then they go, well, those long hairs on the internet we got it from, they've completely rewritten the API. So we can't. It's just not going to work. And of course, we're aware of this arms race, so speaking for the long hairs on the internet, we are going to keep changing things, but we've obviously got to find some way of actually managing this change so that people can actually keep using these modules. So the basic plan we're looking at, what we've decided to do, we've actually split the Java effort now into two parts. So we've got a 1.0 stream now, which is basically the module as it exists, plus we're doing steady changes to that, and we're going to incrementally keep upgrading that probably once every 2 years from now. And then we've got the 1.1 stream, which is where we're going to try and deal with the issues that are going to come up about the new algorithms, where really we have to make API changes. But at least, when you're going from 1.0 to 1.1, you probably feel like you should be doing some work. The thing that we want to maintain with the 1.0 stream, though, is so that you don't have conversations where you get told, well, our current version, say you're still using 1.00, which will get archived in 3 years. We're using 1.00, we're about to get archived. We can move to 1.02 and everything will be sweet. You shouldn't actually have to do much more than drop the jar in. We've been very careful to try and make sure there aren't any unnecessary code changes. I'll explain what the word unnecessary means in a minute. A 1.1, on the other hand, is giving us the scope to just act like lunatics, which is quite until we, of course, certify it, and then we'll see what happens then. Now, I said that there's kind of some caveats on this. So, the one thing that everyone has to be aware of, and this is where, again, things like crypto agility come in, is that while we can do our best to actually try and maintain compatibility with the code base so that you can actually take the module and just drop it into your application and everything should be fine, the reality is if the implementation guidance deletes algorithms or deletes modes or does things like this, which your application is relying on, then you're going to have to make that change. So in terms of the way we actually describe products these days, I think if you're trying to design something, you want to talk more about, I want to be using signatures, I want to be using PKI, I want to be using authentication, I want to have encrypted traffic. You don't want to have conversations now about, I want to be using AES 256, or I want to be using DSA 2048. Because there's a good chance that over the course of the next 5 to 10 years, conversations like that are going to become quite meaningless and dangerous. And of course, the reason for that is this quote from Michele Mosca, which I also saw yesterday. Rather than let this turn into one of those situations where, two speakers at this conference are both showing up wearing the same fur coat at the reception, I'd just like to emphasize this point again in the same way that Dita did yesterday, which is that, people are actually starting to put absolute probabilities on what's happening in this arena. So this is probably something we're going to have to address. And even if you could actually get up and go, say 5 years from now we don't actually have any progress in quantum computing because all the progress that they've made in the last 12 months, which has been quite rapid, turns out to be a complete furphy and everything grinds to a halt. I'd much rather be standing here 5 years from now with somebody saying, I told you so, I'm a great quantum skeptic, than standing here 5 years from now going, okay, so, we're all stuck on RSA and it turns out that offers us 5 bits of security. So, how long does it take you to search a space where you've got 2 to the 5 numbers in it? Not very long. You can do it with a pen and paper. It's kind of our responsibility to try and keep this safe. Now, as I said before, at the moment we're actually listed with 7 and 8. So one of the things we're going to do is we're going to certify this next module with Java 11 as well. Oracle have kind of, I don't know how to describe it. Well, they're different. They're not Sun. I think this is one thing. And there's advantages of that, and then there's disadvantages, and then there's just things that are different. But basically, they've announced that they're going to do extended support for 7 and 8. So July 2022 and March 2025. So this will probably be the last module that we'll actually certify to Java 7, because that will actually, the 5-year period will actually get us past to 2023, at which point using Java 7 just simply won't be safe, I suspect. there will be no support for it. Java 8, of course, is going to be with us for a while longer, and it's, as far as we can tell in terms of enterprise level sort of work, Java 8 is probably still the preferred platform of choice. That may change when Java 11 comes out. I mean, some people have been looking at Java 9 and Java 10, but as I've said here, the support for both of those has already expired. So if you were trying to actually deploy something on Java 9 or Java 10, it'd be quite insane. Java 11, though, which is this new thing, which is where, they're going to the long-term support release lists, that's actually going to come out in the next couple of weeks. So we're more or less getting set up now to actually test against it. And that'll actually be supported until September 2023 with extended support till 2025. Now, the thing about extended support is, as far as I understand, Oracle actually planned to charge people for that. So it's not really clear at the moment how the OpenJDK community are going to run with that concept. We may actually be looking at a period where we may end up with Java forking in some sense. So the OpenJDK might decide to go in one particular direction and Oracle may go in another. All right. So just a bit about BCFJA 1.02. As I said, targeted for Java 7, but this will probably be the last one we're going to do for Java 7. We've made sure it's going to work on Java 11 as well. Minor enhancements, bit of performance stuff. There was a slight issue with the NIST CAVP testing tool, which involved somebody adding 1 to the number 39 and getting 40, which ordinarily sounds fine, except unfortunately in this particular case, the constants concerned were base 16. So we're all fixing that. We've added the extra SHA-3 algorithms. NIST has basically released object identifiers and also some test vectors and everything for that since the start of the year. So SHA-3 HMAC, C-Shake, which is a extension to the Shake algorithm. A very interesting one too, I'd have to say. Again, the regular Java API hasn't really caught up with these things. So if you want to be using these in our API, at least at the moment, where it's not exposed via, say, a configuration item or a string, like, say, Diffie-Hellman using Shake 256. If you actually want to actually use the algorithm properly, you'll have to use the low-level API. We've completed the key agreement support, CAS. So we've actually allowed for things like doing ephemeral keys, but using the unified model rather than MQV. Because MQV, of course, causes some people to get quite excited right now, mainly due to patent issues. scrypt augmentation to PBKDF2, very careful about the wording there. scrypt, of course, has actually been released as an RFC in its own right. For people who aren't familiar with it, scrypt is what we call a memory hard password hashing algorithm. So normally with a password hashing situation, you go, okay, I'll take my password, I apply it to a hash function. I'll apply it to the hash function 1,000 times. The idea being that it's 1,000 times computationally harder for somebody to then get a whole list of passwords and then try randomly guessing by hashing every possible combination, seeing if they can get one that matches. You introduce a salt as well to just mess things up for people a bit more. The reality is, though, that largely thanks to Bitcoin, people have worked out that you can actually get, you can actually generate hashes incredibly fast by using what are essentially graphics cards, which is a bit annoying for gamers because the price of graphics cards has gone up. But for Bitcoin miners, it's great because they've suddenly got access to very high special purpose, fast, massively parallel hardware. For the rest of it, what it means is that, you know, it's possible to do dictionary attacks and generate rainbow tables and everything on passwords with iteration counts that would actually bring any server just trying to log in a single user to its knees. Now, the one thing that these things are vulnerable to, though, is the idea of actually going, okay, as part of my munging of the password to produce a key or to produce a match with what I've got stored in my database, I'll actually also incorporate 10 meg of data. Servers can cope with that a little bit better, but special purpose hardware and things like GPUs, no chance. So script basically incorporates this step. Funnily enough, what this also means is the iteration count for the actual SHA thing goes from being 10,000 to 1, because it's actually it's the memory usage which is in fact the thing that really makes it secure. Anyway, script is actually defined on top of PBKDF2, which is the actual algorithm that the NIST have ratified as being the one you use if you're dealing with passwords. So we've actually found that we can actually enable that in approved mode, so we're in the process of adding that as a security enhancement. And then, of course, the other thing we're trying to do to just future-proof the module a bit more is we're adding support for the algorithms in TLS 1.3, which, against all odds, was actually standardized last month. I can't believe I'm actually standing here saying that it's finally been ratified, but it has been. The most important one of those is Edwards curves, and of course Poly 1305 and char 20. I say Edwards curves are probably more important because I think the likelihood is that NIST are probably going to incorporate those into the NIST family somehow. They're very well studied curves, and they're also very efficient. So this is just a quick example of how you use the script support with BCFKS key store. So BCFKS is a format which is basically all in ASM1 because it's crypto. Why wouldn't you use ASM1? You might as well, if you're going to be making your data really obscure, you might as well use a really obscure, complicated and baroque data format as well, just to really finish anyone off. Using the load store parameter thing, we've actually been able to introduce script into the key storage thing. So this means that you can actually now securely write out key stores which are actually memory hard. As you can see, there's some different parameters here. The last two at the end, 8 and, wait a second, let me. All right. Does this actually work? No, never mind. I can do this. Yeah, the extra parameters are basically associated with parallelization and also how much memory you want to allocate to the process. So it's very configurable. And as I said, the nice thing about doing it this way is it means you wind up with a key store where, at least for the moment, you're going to be quite safe against people that are actually trying to attack your keys using special purpose hardware by trying to work out what the actual password is and getting a match, unless they can actually allocate the huge amounts of memory that are required as well. So another thing we've done as part of 1.02 is we've written some code. People who saw my talk last year, I gave a very brief outline of how you could actually use the new Hope Key Exchange algorithm to augment. I love that word. I got that from a testing lab, as long as it's an augmentation. They don't like to hear enhancement, apparently. If you're enhancing a NIST algorithm, it sounds like you kind of know something better than they do, and they're a bit sensitive about that. They like to enhance things themselves, but they don't like other people talking about it. So I gave an outline on how you do that, and we've actually developed a formal API now, which we've actually designed so that it actually fits with the actual NIST framework. There's two public operators for that. There's the NH other info generator, which is what you can use with regular key agreement. And there's also this thing called the NH secret key processor, which takes advantage of another NIST paper, which a standard which concerns the way in which you can actually generate secret keys. So, what's going on here? Right. So this is an example of the NH other key info generator, and basically key agreement's done in two parties, party U and party V, who I'll get to in a minute. Probably the most important thing about this is the fact that you actually have this call called get sub priv info part A, and then for part B there's a get sub priv info part B. And then you do what's essentially a key exchange, but it's hidden, because one of the important things when you're dealing with certified modules is you have to define very, very strict boundaries on what's a cryptography algorithm and what's a utility. So although this stuff all uses New Hope, it's actually hidden under the covers. You can't actually tell. So what it really looks like is that you're just throwing around some numbers and you end up with a shared secret. Now, I know that sounds a lot like a regular key agreement algorithm, but in the context of the key agreement standards that are published at the moment, there's this supplementary private info field which is defined as a shared secret that has been agreed by the two parties involved in the key exchange through some other mechanism. And that's actually munged into the, that's mixed into the key generation step so that you have your shared secret, which is generated, say, using Diffie-Hellman key exchange. Then you have this other string of bits, which is generated some other way. You mix those two together and the result is the key. So the nice thing about this particular approach is that your worst possible outcome, so this is party V, as you can see it's very similar. The nice thing about this approach is that your worst possible outcome is it will be as secure as the standard FIPS algorithm is. So if we wake up tomorrow and it turns out that New Hope in fact should have been called No Hope, which I doubt because it's a very well studied algorithm. But yeah, with quantum computing and post-quantum algorithms at the moment, you know, anything could happen. If it turns out tomorrow that New Hope was a waste of time, then the worst that would have happened to your data in this case is that it would be as secure as the key exchange mechanism was that had already been certified. On the other hand, if we're standing here 10 years from now and it turns out that New Hope actually did end up being one of the algorithms selected for the NIST competition and no one's ever found a breach on it, then even if the elliptic curve side of the key exchange collapses completely, your keys in this sense will actually still be secure. So, of course, the other point I should make is that the way this thing's designed to work is the New Hope keys are, of course, ephemeral keys. So there's no risk of violating things like forward secrecy or anything. You actually get your full bang for buck in doing it. So the other one we've got here, this is so that as a mechanism to help people that are dealing with RSA-style key exchange mechanisms. This takes advantage of a thing that's in SPA 800.131, which is basically a thing on generating, part of it's about generating secret keys. One of the things that NIST actually allows for is the idea that you might want to tag every key that you're producing by XORing it with some other value. So in this case, this provides a mechanism also for generating a value which you can then XOR with the secret key that you've recovered, and providing, of course, both sides are doing the same, XORing in the same value. Everything will actually work as it did before. But again, if your RSA key is actually recovered, then all that's going to happen is the best summary you can recover is that side of the equation that was actually in the RSA key. They still won't be able to recover what was actually generated during the New Hope exchange. And again, the same thing applies. If it turns out the New Hope doesn't work, then nothing's worse, if that makes sense. On the other hand, if it turns out the New Hope has worked, then yeah, you've saved yourself a lot of grief. And also, I think the other thing I'd have to point out, this actually does introduce a level of forward secrecy into the key exchange as well, because again, you've actually introduced an ephemeral key agreement into the step. All right, so quick look at BCFJ 1.10. New algorithms, ARIA, the GOS standards, of course, for people who care, they're expiring, all the 2001 ones this year. And we've got implementations of the 2012 ones already in the regular Bouncy Castle API. There's still a few things that we haven't completely settled about the way they do key exchange, secret keys. This is partly due to the fact that we've got no one on the team that talks Russian, I suspect. And it's also, it's hard. Some of these algorithms are hard to deal with because you don't really get a lot of examples in the field. Most of the people we work with that are using these algorithms are, of course, people that actually have to talk to Russian banks and things like that, but it's very hard to get a Russian bank to talk to you. In fact, being in Australia, and I think at the moment there's probably some Russian banks that I'm not even allowed to talk to anyway, because I think some of them are actually sanctioned. SM2, SM3, and SM4, of course, which are the Chinese algorithms. And then there's post-quantum. So I'll just speed it up a little bit. This is just a quick example, though, the format preserving encryption. So just to try and get across the idea of how the algorithms are starting to change in terms of their look. You can see here that although it says FIPS AES, after that, everything kind of looks, if you're used to writing encryption code, everything looks really, really weird. There's an alphabet mapper, which actually defines the range of characters that you're actually allowed to produce by the encrypted code. So the idea of format preserving encryption is if you've written your database and you've gone, okay, here's, say, for example, my 16-character credit card field, it will always have the digits 0 to 9 in them. You want to start encrypting those, but at the same time, you still want to respect the fact that the database won't cope with anything other than 0 to 9. This algorithm will allow you to do it, but as you can see in the way that you actually have to do things, it looks quite different from just going AES, give it an IV, call CBC mode, produce a bunch of bits, and off you go. There is no equivalent to this in the JC at the moment, and even in terms of the 1.0, the 1.0 stream API that we have, we didn't really have a way of constructing this algorithm, if it makes sense. We actually had to rejig some stuff to get it to work properly. Timelines. So, a couple of weeks, I reckon, we're on track. You can go to the countdown page for Java 11. It says, yep, it's coming. I should warn, of course, that doesn't always mean it's coming, but I think we all know that. With 1.10, we're probably going to try and wait for the post-quantum competition to get the shortlist down to a size where we can actually go, okay, these are probably the algorithms we're going to need to be modeling, because we are cognizant of the fact that if we actually certify 1.10, then we're going to be in the same position that we are currently in with 1.00, which is, while we can probably make additions to the API, we can't actually change it much. So trying to find a stable point, and we think October next year is probably the time for that. There's snapshot releases for both these already under early access. If you're going to use them, though, just remember 1.10 is experimental. Android's moving along. We've now got certified versions of the Android API. That's called Stripey Castle. As you can see, there's some zebra there. That's a tribute to the primary sponsor for that one. Regular Bouncy Castle, basically at the moment all our work in that's going into TLS 1.3. So as I said, just standardized. Everyone's in a massive race to do that. NIST have actually said that you're meant to be using TLS 1.3 by, I think, January 2020, which is going to be pretty exciting, given that there's virtually no actual working implementations at the moment. We're doing ongoing work on the C# APIs again, finally. C# user base tends to be mainly banks, organisations like Visa and that, so we're expecting what we'll probably do there is just more work on the financial stuff. So the X9 3.1 fix, for example, is important to them. Format preserving encryption is important to them. We think we're going to have more luck integrating format preserving encryption into this one, because with C#, because of the way the generics are constructed, there's a lot more agility in the way you can actually rephrase the API. So we think we'll actually get away with that. Things that we're pondering. As I said, TLS 1.3, January 1, 2020, yay! But, people are still trying to get off TLS 1.0 in the US government. It's not easy. It's just not easy. The added problem with TLS 1.3 is, of course, that it actually only got formally ratified about 4 weeks ago. And there are no, what I would call complete implementations of it at the moment. There's alternatives to the post-quantum competition. So yeah, LMS is going through the RFC process. XMSS is going through the RFC has come through the RFC process. We have an implementation like that. Somebody found a flaw with FF3, which is one of the format preserving encryption algorithms. The same people that found the flaw published a paper concerning it, but also provided a solution to this. NIST acknowledged the paper, published the thing saying that it was all under review, and everything ground to a halt. They still haven't actually officially said what their position is. Are they going to throw FF3 out? Are they going to update it correctly, which seems like the most likely thing? Or are they just not going to do anything and keep us all in suspense? But clearly this affects both our ability to get it certified, and it also expects the kind of business decision you're going to make if you're actually trying to use format-preserving encryption. I mean, if you bet the farm on FF3 and they turn around and take it out, then you're going to be in that situation where I'm going to have that really sorry phone call with you where I say, well, I'm sorry we had to drop support for it. Finally, yeah, just a quick lesson learnt. And this has kind of come up too before during the tech days. It's just this fact that, yeah, all right, it's certified. There's a security policy, there's instructions, there's all these documents, if you can keep yourself awake long enough to read them, which tell you exactly how things are meant to be done. The API stops people from shooting themselves in the foot in a lot of ways because there's an actual FIPS module. Bouncy Castle itself was, of course, a lot more flexible like that. But the FIPS API is really locked down. The reality is, though, that we found that people are quite capable of finding newer and more exciting ways of shooting themselves in the foot. And you still get these really weird bug reports where somebody will claim that one thing you're doing is a security issue, and you'll have another vendor with equal competent staff who are saying, for God's sakes, don't change that because it'll cause a security issue. Yeah, it's fun and games. Anyway, thank you very much. I've gone slightly over. I apologise. But anyway.
Well, thank you, David. I already gained some help for our deployments. Your slides here, what to plan for the future, so to say. Yeah, I have a couple of questions actually, but first, do we have any questions here on the floor?
Is there anyone who wants to accost me during coffee, please feel free to do so. I may be talking a bit fast though, you might have to tell me to slow down a bit. I was a bit G'd up after one of these. Oh, yep.
All right.
Okay, so if your module is approved in FIPS mode, does it require a certain runtime environment? So let's say it's approved for Java 8 version something, and then what happens if Java gets updated by your OS provider?
Okay, so NIST's position on that is that the Java virtual machine is what they call a general purpose computer for the purposes of the certification. So when we certified on Java 7 and Java 8, that meant that any JVM which was compliant with the Java 7 or the Java 8 spec, be it from Oracle or IBM, for example, or the OpenJDK, your application would be regarded as FIPS certified if it was running on top of the module and you were using the module in a compliant fashion of what's in the security policy. So our security policy is not very complicated. Basically, it just says don't import IVs from GCM because for GCM, for example, because NIST will get really upset if you do. It's kind of things like that. Their position about the actual JVM is that, yeah, it's like 1.9, for example, it's not certified, 1.10, 1.11, but minor releases of the actual JVM, because they don't change the integrity of the general purpose computer, you're quite safe.
Yep.
Yeah. And I mean, there's lots of compelling reasons generally for maintaining the upgrade path, because there's plenty of other things that can go wrong.
Okay, then, well, I have one question. I noticed you mentioned Stripey Castle there, and since we see a lot of more and more people, embedding Bouncy Castle API, which makes it collide when you try to do something more modern than what they have embedded. So is Stripey Castle going to be a kind of official supported version of Bouncy Castle for us who don't want to?
We're still getting the certifications finished, but it will be. So we're going to actually make it available and everything properly. I mean, Stripey Castle is just that classic oh my God, Google, what have you done to me situation. Because Google, of course, released Bouncy Castle as part of Android when Bouncy Castle 1.45 came out. And then, of course, Roberto Tiley thought, well, this kind of sucks because there's a lot of things in regular Bouncy Castle that I'd really like to use. And so he did Spongy Castle. And then, of course, people came to us about the idea of having a FIPS-compliant version of Bouncy Castle running in Android-style environments. And so we wrote to Roberto and said, look, do you mind if we use Spongy Castle for this? And he went, no, fine, go ahead. Thought, this is good. So we thought, all right, we'll call ours Spongy Castle as well, you know. And then, of course, what happened was, as we got a couple more vendors interested in the whole FIPS Android thing, turned out that a number of them wanted to be able to run Spongy Castle applications as well as Bouncy Castle ones from Google, so Stripey Castle.
Great.
Yes.
So we have one more question here from the Slido. Is there any chance that soft key stores may get FIPS certified in the future?
Any chance of?
Soft key stores.
Soft key stores.
I guess that's...
Okay, so yeah, as in key stores created in software,
yeah,
as opposed to HSMs. Okay,
exactly.
so NIST's position on that, as far as I can tell, is that providing you're using the correct algorithm, which in their case for converting passwords to keys for storage on disk, then whatever you're doing is actually FIPS compliant. So PBKDF2, of course, as I said, is the algorithm that FIPS use. This creates a lot of excitement because a lot of us are aware that there's another algorithm, another key store format called PKCS12. But the reality is that the algorithms that PKCS12 uses are not actually FIPS compliant. So yeah, the BCFKS format that we use specify is actually designed from the ground up to be FIPS compliant. And as I said, fortunately, because of the way scrypt has actually been designed, you can actually treat it as an augmentation. Note I said augmentation again, not enhancement. You can treat it as an augmentation on top of the actual NIST algorithm. So BCFKS, as far as we're aware and as far as we've been told, is actually regarded as an acceptable soft key store format for doing FIPS compliant keys. Having said that, look, in a lot of cases though, you probably want to be using a HSM if you're really worried about key security. But yeah, I mean, there's a lot of situations where you obviously can't do that too. Well, thank you very much.
Yeah. Thank you,
Coffee is
David.
ready.